let's talk about section 10.4, hypothesis testing for the population proportions. Now, we've looked at hypothesis testing before, but this time we're going to concentrate on for proportions in particular. So understand that for hypothesis testing for proportions, we have seen in the two previous sections how to apply the principles of hypothesis testing in regards to a population mean. Now, in this section, we're going to actually switch it out. Instead of it being a mean, it's a proportion of a population. So you're going to recall basically your general hypothesis test outline is the first thing you want to do is state the null and alternative hypothesis. Step 2 is you have to determine what distribution is happening. So what type of test statistic am I looking at? How is that level of significance being stated and all that? Now, step 3 is where you gather your data. This is again normally found in your problem, and you're going to calculate the necessary sample statistic. And step 4, draw the conclusion and interpret it. Okay? Now, recall that the best point estimator for a population proportion is a sample proportion. That was that p hat we were talking about. Now, in this section, we are going to perform that hypothesis test with a population proportion. So because we're dealing with a proportion of a population, there's going to be a couple of extra conditions that are a little bit different. First of all, by basic general idea, everything has to be a random sample. So everything has an equal opportunity being chosen from the population. However, this one's a little bit different. So in this case here, we are not going to be given averages of a mean. We're going to be given a proportion, which means basically we have binomial conditions are met. Now, if a binomial condition is met, it's either this or that. Remember, binomial means there's only two choices. You have this or that. You fail or succeed. Like those are the only two options. Now, with that, that is going to kind of guarantee like a different type of sample size. To ensure that your sample size is large enough, basically your n times your p has to be greater than or equal to 5, and your n times your 1 minus p has to be greater than or equal to 5. Remember, n is going to be the size of your sample, and p is going to be the probability of success. Okay. If these conditions are met, and we are talking about sampling distribution of a sample proportion, and it's approximately normal, we're going to use our test statistic for this is a population proportion is a z-value. Okay, so it's a z-score now. Now, remind yourself, because we're talking about a z-score with p hat, that does change up the formula to get that z by hand. So if I'm doing it by hand, it's going to be p hat minus p divided by, now remember this standard deviation was really odd. This one was the square root of p times 1 minus p divided by n. And again, all of that's underneath that square root symbol. Again, p hat is going to come from the sample proportion. P is going to be the presumed value of the population proportion, and n is going to be your sample size. If you happen to forget, so just a reminder of where p hat actually came from, because a lot of students happen to forget that, is that remind yourself that pretty much p hat came from x over n. And normally p hat is given as a fraction or a percentage. So in each scenario, identify which distribution should be used to test your claim. So let's start with this first one here. So we have at least 15% of listeners of a nonprofit radio station generally favor commercials for other nonprofit organizations on the station. Now, a local nonprofit radio station believes that the less than 15% of listeners favor their commercials. Now, the station plans to survey a simple random sample of 50 of its listeners to test the claim. Now, notice some key things, and again, this is kind of where I'm kind of drawing my attention. At least 15% of these, and a random sample of 50. So first of all, they don't actually say, well, we believe the mean is greater than 200. We are talking about percentages here. So because we're using percentages, I am automatically in proportion world. Now, that one, as we were talking about, the claim is referring to a population proportion. So thus we must use make sure the test conditions are met. So the first thing you want to note is it was talked about as a simple random sample. They planned on making a survey of 50 listeners. Now, I do want to make sure that they're claiming that the 15% reference there, so that's 0.15 is my p-value. I do need to calculate whether or not I can actually run this hypothesis test, okay? So, but basically, so we can determine whether or not we can actually calculate it, what you're gonna do is to calculate the following is you're just gonna take n times p, so 50 times 0.15, which is 7.5, which is still bigger than 5, so we're good to go. And then we're gonna say n times 1 minus p, so 50 times 1 minus that 0.15. And we do notice that gives us 42.5, which is still greater than or equal to 5. And again, because both of these numbers are greater than or equal to 5, all the conditions are met, so we can basically run this as a normal distribution to test the claim itself. So let's read this one and see, can we test the claim or not? So a college paper reports that at least 10% of students turn off their cell phones during classes. Now, aggravated with the number of cell phones that ring during his class, a professor believes that it's actually fewer than 10% of his students turn off their cell phones during class. And he plans to test his claim by asking a simple random sample of 20 of his students to show that their cell phones to them on one day during his class. Now, again, noticing key things here, making note, and again, this is kind of where you're kind of playing the idea here. We see that at least 10%, at least 10%. So that is our p-value that we're looking at, and our sample is 20. Now we have to test whether or not we can actually run this. Okay, so my p being 10%, do remind yourself to switch that to a decimal of 0.10, and my n being 20. Now I am going to start off by basically just taking that n times p, so 20 times our 0.1, which is 2, which is less than 5. Okay, now this is very important to note because the conditions that the sample size is not large enough here. Okay, so it has to be greater than or equal to 5. So in our case here, a normal distribution cannot be used to make this sample. Now, if it is possible to increase the sample size, then we would be able to run the hypothesis test as a normal distribution. But if it's not, otherwise other methods are necessary, and we're not going to learn about those other methods for the moment. Okay, so our last one here is the mean amount of rainfall in southern part of Texas during the month of September is commonly believed to be no more than 3.02 inches. Now, a meteorite claims that the amount of rainfall this September, claims that the amount of rainfall this September has been higher than normal. He tests his claim by measuring the amounts of rainfall in a simple random sample of 12 locations across the region. We're going to assume that the population standard deviation, we do not know what that is, but the population is approximately normal. Now, again, as I read through that, the first thing I began to notice, and again, this is kind of where you're playing along and seeing for some key things here. Do you see anywhere in this problem a percentage? And all I have is that he took a sample of 12, but we don't know what proportion of the 12 was higher or not. We're not actually looking at something that is exactly like this or not. We're literally testing how many inches. This is not a discrete variable. This is actually a continuous variable because, again, it's a measurable variable. And that changes things up a bit. So the claim here refers to a population mean and not a proportion. And this actually brings us back to 10.2 and 10.3. So the first question I'm going to ask myself is, did I know the population standard deviation? And since I do not, but we do know it's normal in shape, we can actually use the student t distribution here. Again, this is what you're doing when you read all your problems. Is the first thing you want to do is you always want to kind of look for what conditions are being met. And once you have seen those conditions, is it a z-test, meaning I know the population standard deviation? Do I not know the population standard deviation, but we're still looking at an average of something or mean? Or is this a proportion problem? And again, if it's a proportion problem, we have to double check, can we run it using the numbers we have? Now, again, I am going to remind you of that p-value versus the alpha. If the p-value is less than or equal to your alpha, meaning the alpha is larger than the p-value, we're going to reject the null. And if the p-value is bigger than your alpha, then we're going to fail to reject the null. This has not changed. Every test we run, this is the same every single time. Okay, so a local school board has been advertising that at least 65% of voters favor a tax increase to pay for new school. Now, a local politician believes that less than 65% of his constituents favor this tax increase. So to test his belief, his staff asked a simple random sample of 50 of his constituents whether they favor the tax increase. 27 said that they vote in favor of the tax increase. Now, if the politician wishes to be 95% confident in his conclusion, does this information support his belief? Okay. First of all, as I'm reading through this, the first thing I noticed was at least 65%. That's talking about kind of a proportion right there, right? All right, we have a sample of 50, but 27 out of that 50, so my p hat would be 27 out of 50. Everybody see that? But I also notice here that we want to be 95% confident. They did not give me my alpha. But remember, we know how to find our alpha if we know the confident level. So the first thing we know is that we are able to see kind of a hypothesis test. Okay. Does this information support his claim or his belief? That is a hypothesis test question. So step 1, state the null and alternative hypothesis. Now, in our case here, the politician's belief is at less than 65%. So ladies and gentlemen, that is your research hypothesis, is that, again, we're talking about a proportion. So we're going to say P is less than 0.65. And again, the logical opposite of that was that our P was greater than or equal to 0.65. And it did say that they believed it was more than 65%. So now, the second part I do on my test is I always determine whether or not I can run the test. And this is so I can determine what type of level significance and test statistic I need. Now, in our case here, guys do understand that all the conditions for a normal distribution in a z-test statistic are allowed. Now, again, I said z-test statistic. That does not mean we're running a z-test, so please understand that. Again, this is a proportion, slightly different here. We do have a random sample of 50 constituents, so we are going to need to double check, was our sample size large enough? So step 1, make sure that P was 0.65 and our N being 50 there. So I'm going to literally check the sample size. So I'm going to say 50 times our 0.65, which is 32, which is bigger than 5, so good. And then my 50 times my 1 minus 0.65, which was 17.5. Again, that's bigger than 5, so we're good. So all the conditions are actually met, and we can continue on noting that we're going to have a z-test statistic when I get done with it for a sample proportion. Again, not running a z-test, but a z-test statistic. Okay. We also know that we're running a hypothesis test, and this problem gave me the level of confidence. So we do need to figure out what my alpha is. And again, remind you, this is where we learned in chapter 8. Alpha is basically 1 minus our confidence level. So 1 minus 0.95, which means my alpha in this case is 0.05. Okay. Gather your information. So in our case here, we have 27 out of 50, and that's going to be the extra information I'm going to need. If you need to, we can use our p hat here, which is 27 out of 50, which is a 0.54. Again, do not round this p hat unless this is a told to be round, but in our case here it's not, so don't ever round this. So when in doubt, always use a fraction, it's better. Okay, now from here, please understand you're gonna basically, if you do this by hand, the by hand method takes a little bit more time. So the by hand method is you're gonna substitute the necessary items into the formula to figure out what your z-score is. So your z test statistic is going to be p hat minus your p divided by the square root of p times 1 minus p all over n. And again, all of that was underneath the square root there, which is going to give me a negative 1.63. So now this here tells me what I'm testing. Now I still have to go find my critical z value. And to get my critical z value, this is where I have to make note of, well, what type of hypothesis test am I running? Well, in our case here, we are running a hypothesis test that was a left tail. So therefore, the p-value for the test statistic is going to be the probability of obtaining the test statistic being less than or equal to z being a negative 1.63. So our p-value, meaning the probability that our z is going to be less than or equal to a negative 1.63. Again, this is coming from the alternative hypothesis. And to calculate it out, we can either use our nice, lovely table. That works just as fine, or we can use our calculator. Now, if you are going to use your table here, again, remind yourself your table only does show the area to the left, and you already have that z value, so you can take that z value, look it up on the table, and you should get this p value back out. If you're going to use your calculator, hang on a second, I'm going to show you what you're going to do in your calculator. So in my calculator, if I'm just calculating the probability, so kind of figuring out what that p-value is, I can say second vars. Again, this is if I'm looking for a probability. Probability comes from basically this number 2 for a normal type shape. And again, I've got my negative infinity, which again, I'm going to negative infinity because it's a left tail test, up to this value here, which is our negative 1.63. That should be a decimal there, hang on. And again, this was a z value we were talking about here, so I can use 0 and 1 and keep going. And we get that 0.0516, which is again the same thing that I get from the table. Now we just have to basically compare our p-value to our alpha. So again, our p-value being this, our alpha was 5%. So we do notice our p-value is actually bigger than our alpha, which means we fail to reject the null hypothesis. Okay, so this basically means that at a 5% level of significance, this evidence does not sufficiently support the politician's belief that less than 65% of his constituents favor the tax increase. Okay, let's try this again. And again, with any type of problem, it's always best if we can really look through and look for key things. So according to a report published by Mathematical Association of America, so the MAA, 1% of bachelor's degrees in the U.S. are awarded in the fields of mathematics and statistics. Now, 1% of mathematics graduates, one recent mathematics graduate believes that the number is incorrect. Now, there's no indication if the actual percentage is more or less. We just don't believe it's 1%. Now, to perform a hypothesis test, she uses a simple sample of 12,317 recent college graduates for her sample. Now, according to her graduation program from the colleges, she notes that the bachelor's degrees in math and statistics was 148 in her sample. Does this evidence support this graduate's belief that the percentage of bachelor degrees awarded in math and statistics is not 1%? And we're going to use a 10% level of significance, or 0.1 level of significance. Now, this data is actually coming from the status of math intensive majors. So just so you know, like this is actual true sources. back from 2011 that we're getting these from. Okay, so the first thing I always do is state the null and alternative hypothesis. Now again here, basically we were told that we believed that it was 1%, but our person who's running the data basically does not believe it's 1%. So since it's not 1%, to write that, it's just saying P does not equal 1%. So my null hypothesis is going to be P equals 0.01, and my alternative, or the testing one, which is going to be P does not equal 0.01. Now, the second thing I need to do is we are going to determine what type of problem this is. So do I need a Z, a T statistic, like which one is it? Now, because this is a proportion, we are going to say that this is going to be a Z statistic. Now, I do need to make sure that the conditions for the sample size are met before I can run this through. So I need to make note of my sample size, which was 12,317. And I need to make note of my P, which is 0.01. And to make sure the conditions are met, I'm going to say N times P. And then I'm also going to say my N times 1 minus P. And if either one of these numbers is less than or equal to 5, we cannot run this. Now, due to the large sample size here, it has been obvious that both of these conditions are super met and easily satisfied, which is awesome. So that does mean that we have the conditions that we're going to get a Z test statistic. And we also are going to make note that our alpha for this was a 0.1 or 10%. Okay. Now, with all of that, you're going to gather your data. And again, we do know that this was a sample proportion, and our data showed that 148 out of that 12,317 graduates are going to obtain a degree in math or statistics. Now, at this point here, I do want to point out that you have the option to do this by hand, or we can run it through the calculator. Now, I want to show you guys the calculator method. Okay, so you should see a calculator on the screen. Now, with the calculator, again, the first thing I'm going to do is I'm going to clear everything out. I just want to make sure it's all super clear. Now, again, I'm going to show you, after I run the test, I'm going to show you very, very quickly the screens of how to get this by hand, but I do want to still show you by the calculator method. So we established that this is a proportion, right? So since this is a proportion, that means that we got p hat and stuff. I'm going to go to stat, I'm going to arrow all the way over to test, and I'm going to scroll until I see one prop Z test. Again, it's got to be a 1 because we're only doing one proportion that we're worried about here, so one variable. So one prop Z test, and again, we're running a test, so I'm going to hit enter. Now I'm going to type in what my null hypothesis was, which was 0.01. I've got my X, which was 148 out of N, which was 12,317. And then our alternative hypothesis was not equal to P. And then I'm just going to go down here and click calculate. Now, when I run that, you'll notice that it's going to come out with my Z, my P value, and my P hat. Notice there's a little hat there. It's very small, but again, notice it. And again, notice that this P hat and that P hat should be identical. The calculator literally runs it, and we have the same thing here as well. Okay, now if you're going to do this by hand, please note that by hand, you want to make sure that this P hat, you have a ton of decimals. The calculator is going to be the more accurate way to run this because it's going to know every decimal and not have any rounding errors. But if you're going to do this by hand, please make sure that you write down as many decimals as you can here. I do recommend that if you are going to do this by hand, that you want to round the sample proportion to at minimum 6 decimal places. If you round it 3 decimal places, it's going to give you a rounding error when you calculate the Z-score by hand. Now, to calculate the Z-score by hand, that's where that really crazy looking formula comes in. And again, this is where if you just run the one prop Z test in the calculator, you can bypass this formula that you see here. Okay, now once you have that Z value, again, this is the critical, this is my test value. So then I have to basically find what's the probability that this test value happens. So this is where the alternative hypothesis test tells what's going to happen here. And you're going to have to run the p-value for this. And this gets a little weird to do by hand. So this is why, again, I do find it a lot easier if you will just please use the calculator. Again, the steps for how to do this by hand are always in the tutor section, but the calculator, you see all of this information that I'm going through here, I can go so much quicker. So instead of actually, in this case here, this is a two-tailed test. I basically need to find the area from here to here and then take that and multiply it by 2, because this area from here to here and here to here is going to be the same. Okay, get that number multiplied by 2. And again, as I bring back up that calculator for you to see, guys, I didn't even have to run a normal CDF. I can see that this here, my p-value, is the p-value the calculator gave back out. And this one's going to be even more accurate because it's got a lot more decimal places. So this is why I highly recommend the calculator over the by hand method with the table. Okay. Now, once you've noted your p-value, what you're going to do is you're going to say, is my p-value, is it bigger than the alpha or not? In our case here, as we compare our p-value to our level of significance, we do see that our p-value is less than or equal to our alpha, which is 0.1. So since our alpha is bigger, we are going to reject the null hypothesis. Now, what this means is that there is, at a 10% level of significance, there is enough evidence to support the belief that the percentage of bachelor's degrees awarded in the fields of math and statistics is not 1%. Again, notice despite the sample proportion being larger than the assumed population proportion, our conclusion only references actually the null and alternative hypothesis. We actually do not mess with it at all, saying that it, just because this sample is, that sample could be a fluke, and that's why we always test it. Was this sample, is it far enough significant to say that it worked? Do understand that the calculator is going to be a great way to run it, and the calculator is going to be quicker. Okay. You actually need less information to run it in the calculator, and there's not that crazy formula than if you do it by hand. If you do this in the calculator, you no longer need to calculate the sample proportion first, so you don't have to worry about p-hat because the calculator does it for you. In fact, all the required is presumed values of the population proportion and the null hypothesis. And again, you'll do note that it will use like p sub naught, meaning to reference the null. N is still your sample size, and x is the number of members that are interested in whatever our value is. Okay, so again, as you guys saw me, a quick recap. Basically, the last thing is the report said 1% of bachelors are rewarded. The claim was that it was not. The sample size was this. They said that 148 were given that graduate of that award of a math or statistics bachelor's, and we had our alpha being 0.1. Notice that's pretty much all the information I really needed to pull out of it. And again, pretty much putting it in the calculator, doing exactly what we did, is literally stat arrow all the way over, but look for number 5, one prop z-test. Okay. In our case here, again, very nice, straightforward, and again, you can choose to do the draw. I do find that just calculate is what you need. If you choose to draw it, that's your choice. And again, the output screen is going to look something like this. It does kind of give us all the information, and again, I really want to pay super close attention to that Z and P, because those are what I'm putting in my actual homework. Those are the stuff it wants to know. So let's use the calculator to help us out here, and let's actually work ourselves out. So a Crime Watch group believes that the percentage of all inmates released from prison who were released because of their sentences expired was higher in 2008 and 2009 for the whole U.S. than it was in the state of Florida. Now, between July 1st, 2008 and June 30th, 2009, 63.9% of all prison inmates released in Florida were released because their sentences expired. Now, suppose that a simple random sample of 36,400 463 prison inmates in the US who were released during the same time period, so say 64.6% were released because their sentences were expired. We're going to use the calculator to run a hypothesis test to determine if the watch group's claim is correct at a 99% confidence level. Okay, and again, these are actual true statistics, so like, guys, I'm not making this stuff up. This actually comes out of actual real statistics. So first thing I'm going to do, state my null and alternative. Now, as I look at my null hypothesis here and my alternative, that's kind of like what exactly were they want to know? What was the claim? And I noticed that it talked about the proportion of Florida was 63.9%, meaning that that was kind of like who was released. And somewhere it talked about, well, they believe it was higher for the whole. So that mathematical belief of being higher is going to be that research hypothesis. So we have our two hypotheses as your null is P is less than or equal to 0.639 and P is greater than 0.639. Again, changing it out of a percentage to a full decimal. The second thing you're going to do is basically determine, can you run a z-test or a t-test or a one prop z-test, and then also state your level of significance. Now, in this case here, we do realize that it met the binomial condition area of it gave me my proportion. So that's going to meet that normal distribution. It will be a z-test statistic. But because it is a population proportion, we do want to make sure that the sample size was large enough to begin with. So to check your sample size being large enough is basically we take our n times our p and then our n times our 1 minus p. And in this case here, again, it is super large, so it meets our conditions very easily. Okay, so that tells me that it's going to be that one prop z-test that we're going to run, and so that means I'm going to have a z-test statistic when I run it. I do notice that they gave me the confidence levels, so I do need to figure out what my alpha is, or my level of significance. And remember, alpha is just 1 minus that confidence level, so 1 minus 0.99, meaning my level of significance will be a 0.01. Step 2 is just going to be gathering up that data, and again, really in the calculator, all you really need is what your n, your x, and your p naught is, and also what type of, is it greater than, less than, or not equal to. Again, the calculator will run pretty much everything out for you, so that's a really nice part about it. The only thing that we have a little bit of an issue with is that in our case here, this one did not give me X. They gave me that 64.6% of inmates were sampled, were released due to expired sentences. Now, again, the problem in particular is that we need X. We don't need a percentage. We need actual, what is the X number here? So in order to get this to work, I'm literally going to take that 64.6% times my sample size. Now you're going to get a number and you're going to need to round that number. Okay, so I got 23,555.098. That is going to round to 23,555. Again, the reason why I'm rounding it to the whole number is because this is a proportion, we cannot enter a decimal, and so we must round to the nearest whole number, and that's going to mean that my X value is at 23,555. With that last bit of information, I can put it all in the calculator and make sure that I'm running what type of test we're running. Is it a 1, 2, or a if it's a one tail, is it a left or a right? And again, that is going to come from your hypothesis, your alternative hypothesis there. So in our case here, as I'm running it, again, I've got the screens up here, but I'm going to walk you guys through this. Okay, so you should see a calculator pop up on screen. So again, stat, arrow all the way over to the test menu. And again, because this is a proportion, we're going to do number 5, one prop z-test. Scroll down, click enter, type in what that p-value is. And again, this is coming from that null hypothesis and alternative hypothesis. That's what that piece of null is. This X value, this is what we kind of just went through to figure out, because again, this has to be entered in and it has to be a number that's just going to be a base number there. No decimal, okay? And then your N, which was in our case here, 36,463, and we said that it was more than. Okay, so again, matching these up to match with what we already have, and then just rolling down and clicking calculate. Again, the calculator is going to spit back out that Z, the P, and the P hat, which a couple of your problems are going to ask for what that P hat is. So it's super awesome there. Now, once you have that information, again, write this down. Remember, for your Z, we do normally round the Z's to 2 decimal places. Your P's, we normally round to 4 because, again, it is a probability. Your P hat is just going to depend on the problem. Most of these, it states, it'll be normally like 3, I believe, was most of the ones I did in the homework. Okay, now once you've made note of those values, again, the values that I really want to make note of is once I've typed them in the calculator, I want to go this, this, and this. Just make a good quick note of those on your paper. And now we're going to interpret and draw the conclusion. And basically, we compare that p-value to that alpha. The p-value was 0.0027. Our alpha came from that 0.01. And since my p-value is less than or equal to my alpha, meaning my alpha is the larger number, we can say that we reject the null hypothesis. This means that the evidence does support the watch group's claim that the percentage of inmates who are released from prison between 2008 and 2009 because of their sentences expire was higher for the whole U.S. than it was for the state of Florida. Again, as you're running through these in your chapter 10 here, be sure to remind yourself that I know that each section is concentrating on one type of test, but you guys still need to take a peek at which type of test I'm running, what has made me choose this test. So when you actually put all of chapter 10 together and start practicing it and being able to identify what those key ideas were, this is why each step, don't just try to skip to the last step or step 3 and just plug stuff in the calculator, is you're wanting to go through the step process because, again, step 2 is where I'm telling you how to choose what test.